Welcome to the NimbleSig III RF Analyzer tracking generator demonstration video. For the purpose of this demonstration, I've connected a 45 megahertz two-pole crystal filter in the test path. To view the response of the filter, we must switch to the tracking generator mode. I do that by pressing the menu button and selecting item 6 on the menu, which brings the graphic user interface up for the tracking generator. You'll notice the center frequency is already on 45 megahertz, the frequency of the filter that we're going to test, and the generator B has already been offset to the desired 10.7 megahertz offset. We have the frequency span preset to 400 kilohertz, which is about right for this test. To view the response of the filter, we press the Go key, which brings up the frequency response display grid, and press the Start key there, which started the generator, and now you're looking at the response of the 45 megahertz bandpass filter. You'll notice the pass band of the response at the top here is showing a loss of somewhere around 5 to 8 dB. Pretty hard to tell on this scale. So to take a closer look at that, we'll switch back to the setup screen, and we'll select a 2 dB per division vertical sensitivity, and we'll decrease the span to 100 kilohertz, and we'll go back to the grid again, restart the sweep, and there's the display of the pass band. You'll notice that the loss is somewhere around 5.5 or possibly closer to 6 dB on the higher peak, and about 6.5 dB for the lower peak, and the valley dips down a little bit below 8 dB. Of interest is to take a look at a specified bandwidth of the filter, and it's specified at the 3 dB points, which if you average the pass band works out to be on the minus 10 dB grid line here. You'll notice that there's 3 horizontal divisions, a little more than 3 horizontal divisions of bandwidth at that point, and that corresponds at 5 kilohertz per division, just slightly over 15 kilohertz, which happens to be the specification for this filter. We'll take a broader look at the filter, switch back to the 10 dB per division mode, and we'll increase sweep width to 4 megahertz. That'll give us a fairly wide view. We'll go back and restart the sweep. Now we have quite a broad sweep here, 4 megahertz of total span. The 15 kilohertz narrow bandpass of the filter now just looks like a spike. And of interest on this particular sweep width is the depth of the dip here, upper rejection band. I guess there must be some cancellation taking place at this frequency. But what's of interest is that the depth of this dip is so deep, it's about minus 98 dB, and it provides a nice demonstration of the dynamic range of the NimbleSig III RF Analyzer. And with that, we're going to take yet a broader look at the frequency response. We'll go out to a 40 megahertz span. I'll go back and restart the sweep, and now we're getting a broader look at the rejection bands above and below the pass band. We can take even a wider look. We'll go to the full sweep width of 200 megahertz, but to do that we have to change the center frequency to the midpoint, and so I'm going to switch it to 100 megahertz, which will allow us to sweep plus and minus 100, or a full 200 megahertz sweep, which I've set there. And now we're going to go back to the grid and restart it, and there's a full sweep showing quite quite a very almost 100 dB loss at the very bottom there, showing about a minus 65 dB loss at the top end. We'll take a closer look at that loss at the top end in a few minutes. You'll notice the legend is in the way of the trace. That's not very good, so we'll move the legend over to the right side. Going back and restarting the sweep, I've got the legend out of the way. This generator has the capability to subtract out any frequency response variations in the test bed and in the instrumentation. To do that, what I must first of all do is take the crystal filter out of the circuit. I've got it disconnected now, and what you're looking at on the bottom there is the noise floor of the test set. I'm now connecting back up to the mixer. I haven't got the connector all the way in yet, and what you're seeing there is a capacitive coupling as I press the connector into place. And of course, once it connects, the trace follows the upper line here on the 0 dB reference. You'll notice now that after I've done the refresh here, that the response of the test set looped back on itself drops off about 5 dB at the top end. Kind of hard to look at in detail there with the legend in the way, so we're going to move it to the bottom, going back and restarting the sweep. We got it in the clear, and it'd also be nice to magnify that, so we're going to go to 2 dB per division, and I'll go back and restart it, and now you can see the response rolling off about 6 dB at 190 megahertz. To compensate for the internal loss and the test lead loss and the frequency response of the test bed, we have a normalize option. I press the normalize label, and now it indicates that it's normalized in fine print under the label there, and you'll notice the line along the top follows the 0 dB line precisely. And if I press the refresh button, you'll see that it's now sweeping directly along the upper line. So now I'm going to put the filter back into the circuit. We'll see the effect of the correction at the top end there. And filter's hooked up, but we're still on 2 dB per division, so I'll go back and switch it back to 10 dB and restart the sweep here. And our legend's in the way, so we're going to put it back up on the top, going back to the sweep, and there it is. And now you notice where it was 65 dB down before, it's actually only 60 dB down. The effect of the test set has been subtracted out. This completes this portion of the tracking generator demonstration, and we'll show you how the tracking generator can be used as a frequency domain spectrum monitor in the next segment. For this demonstration, I have disconnected the IF filter that we were testing before. I'm now injecting a signal from a commercial signal generator set to 50 megahertz at a level of minus 10 dBm. I've already switched over to the tracking generator screen here, and you notice to start with the center frequency still on 45 megahertz, so we must change that to the frequency of interest, which is 50 megahertz. And we'll set the span width up to the maximum for this mode, which is 4 megahertz, and we'll go and take a look at what we get here. And now you see the traditional frequency domain type display with the 50 megahertz unmodulated carrier in the center there. What I'll do is spread that out a little bit by narrowing the span. I'll decrease the span to 1 megahertz, and we'll go back and take another look at it. What I'm going to do now is reduce the level of the signal generator in 10 dB steps down to minus 100 dBm. So there we're at minus 20, 30, 40, 50, 60, 70, 80, 90, and finally minus 100 dBm. So that shows the dynamic range of the display here, and you'll also notice that the noise floor moved down with the as the attenuation was added, because the higher noise floor was emanating from the signal generator. Okay, I'll press the refresh button there and clean that display up. You can see the residual of the minus 100 dBm signal there at the bottom, and which shows the sensitivity of the tracking generator receiver. And now we'll bring the levels back up 10 dB at a time. And we're back up to the reference line at minus 10 dBm there now. We can also, just for interest sakes, take a look at the IF passband of the NimbleSig receiver, which is what we're looking at right now, but I'll broaden it out a little bit. So I'll go back to the setup screen, and we'll decrease the sweep to 400 kilohertz and go back and take another look. And I'll spread it out there a little bit. The legend has gotten in the way again. Doesn't look like there's a good corner to put that large legend. So what we'll do is we'll go back and we'll switch to the small version, and go back and redo the sweep, and there it gets the trace in the clear with the smaller legend. So that is shows the frequency characteristics of the bandpass filter that's used in the NimbleSig III receiver. You see the baseline here at minus 80 is about 10 divisions apart, or a couple of hundred kilohertz wide. It's an indication that the signals need to be separated by a few hundred kilohertz in order to see them clearly with this fairly broad receiver. And that concludes the demonstration of the tracking generator frequency display function. It also concludes the demonstration here of the NimbleSig III RF Analyzer tracking generator mode of operation. Thank you very much for viewing this video.